Okay, this particular example, we've got to integrate between limits. So we're going to end up with an answer because we've got limits here, 2 and 3. So finally we can put values in for our x and end up with a solution. So we're going to come up with a solution for this particular integral. We can't do the integral directly because it's a fraction, and we know the method of partial fractions, so we could try and factorise the bottom, x squared plus x minus 2, by thinking about what two numbers add together to give 1, because we've got 1 lot of x there, and multiply together to give minus 2. So 2 times minus 1 gives minus 2, and 2 minus 1 gives 1. So the factors are going to be 2 and minus 1. So we could factorise it. Let's split it up into partial fractions. The trouble with this is that the fraction's top-heavy. And by that I mean that the largest power of x and the top is x cubed. And the highest power of x on the bottom is x squared. So the powers of x in the numerator, the top part of the fraction, are greater than the denominator, and it's top-heavy. And that means we have to do something before we get to the stage where we use partial fractions. We have to divide the bottom into the top using something called polynomial division. Polynomial is a name we give to an expression like this or this that involves powers of x, x cubed, x squared, x's on their own. We combine all these together into what's called an expression, and we can also call it a polynomial expression because it's got terms involving x cubed, x squared, and so on. So that's all that means. Division means I'm literally going to divide the bottom into the top and find out what I get. So before we do that, what I want to do is to remind ourselves of the technique of long division using numbers for top-heavy fractions. So let's have a look at an example.